Okay, this is the Unit 2 practice exam, page 5. Question number 6. Again, we are talking about the mean pregnancy length in healthy adult women. Still 280 days with a standard deviation of 9 days. Okay, we are assuming the pregnancy lengths are approximately normally distributed, so we're good. 6 is different than 5 because if you look at question A, what is the probability that the average length of a random sample of 36 pregnancies? So we're not talking about an individual. We are talking about a group of 36. Okay. So to start, between 255 and 275, 255 is my lower bound. I'm talking about a random sample. So I want the sample mean to fall between 255 and 275. Okay. Again, our Excel command, norm.dist, because we're working with raw scores. Again, only norm.s.dist if we have z-scores. I got 275. My mean is 280. My standard deviation, though, is now 9 divided by the square root of the sample size. So I'm going to write it that way, 9 divided by the square root of 36, which we know is 6. I just didn't want to skip a step. And then I'm going to subtract off the lower bound, norm.dist. So keep in mind that with a sample, better chance that and I'm going to go ahead and stick the 6 in here, standard deviation, that my mean of the sample is closer to the actual mean. And so now I get 0.0004. Really small, right? Because we have made that standard deviation smaller and crammed everything in closer to 280. What is the probability that the average length of a random sample of 10 pregnancies lasts at least 285? So at least means 285 or bigger. So again, doesn't matter if we have just greater than or equal to. Because we want the right-hand side, I want bigger than 285, I need the area to the right of 285. We still remember that the norm.dist command gives us the left. And so now I'm going to put this in Excel speak. This is going to be 9 divided by square root of 10. And you can leave it just like that. We don't need to calculate a number and plug it in later. Actually, we don't want to do that because then we tend to round and we get something that's not correct. But I do get 0.0395 here when I do that. 3, what is the probability that an average length of a random sample of 25 pregnancies lasts less than 270 days? So again, the probability, it's a random sample, so we have to use X bar. I'm looking for a sample mean less than 270. So I'm looking for the left-hand side, that is norm.dist, 270. My mean is 280. My standard deviation is 9 divided by square root of 25. If you wanted to put in 9 divided by 5, that's fine. 1. Seven. According to one source, debt for adults is normally distributed with a mean of 15,000, standard deviation of 3,650. We want the dollar amount that the middle 90% of debt is between. So here's my middle 90%. which leaves 10% to be split on the outsides. So 5% here, 5% here. I have the probabilities, I want the actual values. So x, that first one, my lower bound, I'm going to call it x sub L, x lower. I have a probability, I am trying to find the value. So we're going to go norm dot inverse. 0.05 is that probability. My mean is 15,000. Oh, I guess I should have put this in dark blue. And my standard deviation is 3,650. I get a lower bound of $8,996.28. My upper bound, and again, because we are accumulating from the left, if I'm cutting off the top 0.5, that means I am looking for the value that has 95% of the area to the left. So 0.95, 15,000, 3650, and I get an upper bound of $21,003.72. 8, and this is one of the things that the book does a little differently. When it wants a z of 0.04, we are cutting off the top 0.04. So this means the z we're looking for, norm.s.inverse, we're looking for a z-score, so the s is for our standardized distribution. You notice when we do this, the only thing that it asks for is the probability, right? And if we're cutting off the top 4%, that means we got 96% down here. That gives us 1.75. A z-score of 1.75 cuts off the bottom 96% of the data, so the top 4%.